Okay, so we began the class on 8th of August, and the unit that we have selected, our first unit, is human environment interaction, and the key concept that we have selected is relationship. The reason why we have selected relationship is that any change in relationship brings consequences, some of which may occur on a small scale while others may be far reaching. So by end of the unit, we will try to understand how the humans have interacted with the environment that they live in, and how has their actions brought into some consequences which have now become permanent. And we will try to understand what is our role to solve some of these major issues. Now, the global context that we have selected is globalization and sustainability. The reason why we have selected sustainability is that one has to understand the resources that the nature has given us. Even if we use them, we have to also create space to sustain those resources. Otherwise, in future, we are not going to have sufficient resources. So our actions are going to affect the future humans. So we will try to understand this aspect here. The AK strand we have taken is ethics. Why have we taken ethics? Because we want to understand the value and significance of living a moral life. What do we mean by this moral life? It means what is our role to ensure that we don't destroy the resources that are given by the nature to us for our living. We have to live in harmony with the nature, with the environment. Going ahead, on 8th August, the first day of the class, we have done two things. One was essential agreement. What exactly are we expected throughout the year in classroom practices? And then we had introduction. And in introduction, we just had a brief discussion on some topics like what exactly is thermal, what exactly is heat, and what exactly is the temperature. And what do we know of this terminology, which is the internal energy? So let us begin now understanding further. On 22nd August, we began the class with a recall. So we began with the question, what is the difference between temperature and heat energy? So we have three concepts here. Remember, we have one concept, your thermal energy. We have one concept, your heat energy. And then we have one more concept here, which is your temperature. If you look at the word, this thermal itself means nothing but actually heat. It leads you to the understanding of heat. Now, thermal energy is the energy in a system. In a system. And where is this thermal energy stored? In the bonds that holds the atom, that holds the atoms. Okay? Then what are the different forms of energy which is available here? The forms of energy that are available are, there are potential energy and kinetic energy. Kinetic energy. Now, what do we mean by this term potential? So, potential means If you remember, any atomic structure will always have, I will just use another color, will always have atoms which are then held together using some sort of bond, right? Using some sort of bond like this. So if we heat this substance, what exactly is going to happen is the bonds will now become longer. They will stretch. See? So they will stretch. So all the atoms, they actually vibrate in their own position. They actually vibrate in their own position. So when they vibrate up and down, and if the vibration is too much here, then there is a possibility that the bonds will stretch. Will stretch. So the bonds stretch. Position changes. Position changes. Bonds are longer. And so the potential energy increases. Potential energy increases. You remember what was potential energy? Potential energy was due to position. Due to position. So thermal energy deals with the potential energies and the kinetic energies that we are having because of the motion here. Then let us understand, if thermal energy is about the energy which is stored in the atoms or in the substance, then what exactly is heat energy? Now, how do we know that heat exists? We know from the difference in temperature. From the difference in temperature, right? That means when energy transfers from one body to another, from one body or object to another, we understand the concept of heat. We understand the concept of heat, right? So for example, let's say for example, if I have to add an example here, I can add an example here. Ice seems cooler when we touch them. When we touch them. Why? Because the heat from our body is transferred to ice, right? So heat is about transfer of energy. Then what is temperature now? We have to understand then temperature also. So temperature, when you heat any object, when we heat an object, the kinetic energy increases, and the kinetic energy of not just one but kinetic energy of all atoms. So if you find the average kinetic energy of all atoms or molecules, then that is known as temperature. That is known as temperature. Okay, so important thing to note. What is the important thing to note now? we have to note that thermal deals with energy of system, heat deals with transfer of energy, and temperature deals with average kinetic energy. Okay, so that is the understanding, of your temperature and heat energy. So thermal energy is also involved, but we discussed more on temperature and heat energy. Okay, let's go ahead now. Now if you go ahead, the next question that we answered was, in which case the average kinetic energy is greater. We all know now that in the cold, the average kinetic energy is lower, as the potential energy increases. Whereas in this hot, kinetic energy is higher, as all atoms or molecules oscillate faster. Okay. So now let us go to the next one. Then on 22nd August, we tried to understand the topic through some examples first. So we tried to analyze these questions. So the question said you are provided with two types of cups. So they gave us two types of cup. One was made up of steel, as you already identified, and one was made up of paper or some sort of a cardboard. Okay. And why would you prefer? So most of you knew that, have already explained me that steel is a good conductor. Is not a good conductor, so it's a bad conductor. Surface may be hot. Surface will not be very hot. But when most of you said that, okay, we are going to drink the cup of, we are going to use this as our tea cup, as we can hold comfortably. Okay, this is what most of you answered. Then our statement of inquiry was this: the consequences of human development can bring about changes that impact on the sustainability of the environment. What does this actually mean? It means that the consequences of what? Consequences of manufacturing paper cups. Why? Because we human wanted to develop technological development. So technological development can bring about changes that impact the sustainability of environment. How? You only said we have to cut trees to manufacture paper cups. Manufacture paper cups. So this is what exactly you have explained. You have answered in that, in the class. So then let us go to the next question that we discussed. Then the next question was, below cup is used in airport or railway station kiosk. Kiosk means a small shop in station or airport. You know, it's something like they have these sort of structures, and then they have like these structures. They're small shops, and then they sell this tea and cup and all those things in the shop. So they are your kiosk. Okay. So just like your CCD, cafe coffee day. Okay. Now, are there any issues? The whole thing was based on issues. Are there any issues? So this is what we were actually trying to answer. The highlighter is not working, otherwise, yeah, okay. So are there any issues? Or is it okay to use these cups? And we all identified that yes, there is issue. But what is the issue there? The issue there is that the issue was, even though the cups are biodegradable, yet they are manufactured from wood or trees. Then the next question that we were looking for is, if this is true, then what is the scientific solution? What is the scientific solution then we have? Or is there no scientific solution at all for this problem? So what we try to do is, we try to analyze that maybe we could use waste material by recycling to manufacture these cups. Or maybe we can design China cups, China material, China clay, porcelain, all those things. Porcelain material, which are easy. Or we can use clay material, clay substance. Nowadays we get something called terracotta. So maybe the terracotta could also be very helpful for us. Okay. So that way we need to build, we need to think how we can design materials to manufacture cups that will be eco-friendly, economical and healthy for use. because that is exactly what our unit is saying here in our statement of inquiry. So sustainability, you see, this word is very important for us. We cannot tend to forget that terminology, sustainability. Okay, let us go now further. Then what we understood from all this, we understood, okay, then we did one experiment also. Yeah, we did an experiment, and that experiment was here. I will do this first, then I will go up. Okay, we did this experiment where we were given two substances. One was oil and one was water. What we did is we found in same amount of time in which case the temperature drop is greater. Surprisingly, we found that oil has very fast rate of drop compared to water. But then what does it mean now then? If this is happening, then what does it mean? It means water can hold thermal energy for longer time. This means its thermal capacity is higher. So now we can go back up and we can write the name of the unit here, because we were supposed to write the name of the unit here. So now the unit name we know is thermal capacity. Topic here, that day's topic, sorry. Thermal capacity. I'm going to go back to that same place now. I'll come back to the other one. Thermal capacity. So look at this terminology, different capacity. This clearly means that different substance have different ability to hold the thermal energy or heat energy. It's okay, you can say heat also. Hold the energy, right? And this is sometimes called as your heat capacity also. Heat capacity. And we have seen water has higher heat capacity than oil. So now you can maybe think, or you can do research between sand and water. We try to have some discussion on some examples also. So some of the examples that we have seen, because water has high heat capacity, that is, it can hold heat for longer time. It is used in many conditions, like we say hot water bag. Hot water bag. It is has a design of something like you have this, and then you have this, and then you have this way, and then that goes, and then you have hot water bag. So you keep the hot water used for medication. Farmers fill their field in winter with water, and that is because during day the water absorbs heat energy and stores during night. So plants do not get affected with drop of temperature. Okay, so this is one of the applications that we have seen. Now this was about thermal capacity. Okay, I'll come back to the graph later. Let us go back up now. So we saw the thermal capacity, that different substance has different amount of ability to hold the heat. Okay, and water has much higher compared to oil, because we did an experiment. Now coming to this, we decided how does heat transfer? That was the question. How does it transfer actually? So we identified that there were three different ways. The first way was, this was a metal rod, and heat travels this way, and then you feel hot. Now this is by direct contact. So by direct contact, when heat travels through direct contact, we call it conduction. Okay, so this was about conduction. Then the second one we saw was a heater used in winter to heat the room, to keep our rooms warm. But then we were very curious here to see two things. One is the warm air and then the cold air. Why is the warm air up and why is the cold air down? That was the question we discussed. And we found out that warm air is much lighter. So it rises up. Cool air is denser, so it remains at bottom. This way, this method of heat transfer is known as convection. The transfer happens due to air current, which arises as hot air moves up, hot air moves up, and cold air moves down. So if you have a heater in a room, let's say this is your house, okay, and you are sleeping here, and you have this heater here. So it's coming like this, okay, hot, cold. So you have to sleep up, otherwise you will not experience sleep up. If you sleep down, it won't be much effective. You have to sleep little up. So the hot air will come, and then by the time it comes to you, your body absorbs the heat, cold air comes here. So it will circulate that air here, okay. That is the job of this heater. Now, so this is convection. Now coming to the third part. We have experienced this in your campfire, right? You sit away from the fire and then you enjoy the fire, the heat from the fire. And we all understood that this is because of radiation. Now the question was, what type of radiation? What type of radiation? So we understood that it is the infrared radiation, okay, and infrared radiation is a part of electromagnetic wave. And this way of transfer is called radiation. So heat transfer also happens due to radiation. Okay. So we have now understood there are three types of heat transfer, right? And what are the three types? So three types of heat transfer. They are conduction, convection, and radiation. So this is what we have now understood from there. So this was about your heat transfer, okay. Now coming down, let's go back to now the last bit here. Here we had a graph, and the graph was about melting of ice. Melting of ice happens when ice absorbs heat energy. What are the different stage now? We have the ice here. So ice will normally be, let us say, at -5 degrees Celsius, and then it will reach up to, let's say, this is not correct, this is also not correct. So here it is at 0 degrees Celsius. Here you are having the melting, because melting starts at 0 degree Celsius. So here you are having ice, here you are having water. If we heat the water, up to 100 degrees Celsius, then what will happen? The water will reach the 100 degree Celsius and then start vaporizing. evaporation. No, evaporation we can't write, we have to write vaporizing. And then becomes here vapor. Now vapor has very high specific heat capacity or heat capacity. Heat capacity compared to water. So we need to be more careful with steam. Okay, the burns can be more severe. Remember that steam can cause more severe burns. Okay, let us think now. Think, what if we are going to what if we are going to cool now? So we are going to have vapor becoming water, becoming back ice. Okay, so how would the graph be there in that case? So now I have to begin from very high temperature, maybe 110 degrees Celsius. This is for steam. Then it will cool. So it will have condensation. It will come down. Then it will have freezing. And then it will come down. So you are having a condensation and freezing, which means vaporization and condensation occurs at same temperature. Okay, melting and freezing also occurs at same temperature. Okay, this you need to keep in mind. Example, water vaporizes and condenses at 100 degrees Celsius. Sorry, my bad. 1 minute, spelling is wrong. I'll just correct it. So, water vaporizes and condenses at 100 degrees. Water melts and freezes at 0 degree Celsius. This also you have to remember. Okay. And with this we ended the first part of the lesson. And then next class when we are going to study about little bit more on the application of sports and more real life. So lab we are going to study on 29th August the difference between heat capacity of ice and a metal cube. Okay, we will study this difference between heat capacity of ice and a metal cube, and we'll compare. We will do a comparative study. Next class. Okay, then in sports, what are we going to discuss? In sports, when we run, we sweat, then we try to apply water on our face to feel refreshed, right? The question is, how is heat transferred from the runner's body? Just think, okay? Another question is, why do we feel cooling effect when we apply water on our face? We get, feel refreshed. We feel refreshed. A soothing effect will be there. We feel refreshed. So let's continue. Continued in next class. We will continue with all these things and do the lab and see more analysis. Until then, goodbye, and hope the concepts are clear to you now. Okay, any doubt, please feel free to ask. Okay, so I'm going to now close this.